And we're looking forward to the continuing program of the Ministry of Education and Research. And the talk of Professor Schieferdecker sets now a great basis for our following discussion, in which we would like to dive a little bit deeper into the question of future visions of quantum computing in Germany and how do we define success. And to help me to lead this discussion, I invited today Ingolf Wittmann, who is a technology analyst at Quantum Business Network and also a chairman of the board of the working group at Bitkom on high performance and quantum computing. Ingolf, you're on.
Thank you very much for the introduction, Natalia. So I do have a quite interesting panel here on board, and I'd like first to introduce the panelists from the participant side. So let's start with Professor Dr. Ina Schieferdecker. She is Director General for Research for Technology Sovereignty and Innovation at the Federal Ministry of Education and Research. Ina Schieferdecker leads the initiative related to modern key technologies like quantum technologies in her department. Before joining the BMBF, she was director of the Fraunhofer Institute of Open Communication System Focus and professor for quality engineering for open distribution system at the Technical University Berlin and director of the Weizenbaum Institute for the Networking Society, the German Internet Institute. Next on the panel is Dr. Heike Riel. She is head of science and technology at IBM Research located in Rüschlikon, Switzerland. Heike Riel is also an IBM fellow, head of science and technology and lead of IBM Research Quantum Europe and Africa. She leads the research agenda and operation for science and technology department to explore new direction to computing. She is a distinguished expert in semiconductor electronic and optoelectronic devices, nanotechnology and nanoscience, and focus her research on advancing the frontiers of information technology through the physical science. From the technology side, Markus Pflitsch. Pflitsch is CEO and founder of Terra Quantum. Markus Pflitsch is a dedicated quantum physics, senior financial executive and deep tech entrepreneur. He believes in competitive advantage of quantum technology and is committed to support the European ecosystem to unlock its value. He studied mathematics and physics and accomplished a research career at CERN, started at the Boston Consulting Group and spent additional years working as senior executive in various corporations. Ultimately, he founded Terra Quantum company and is a deep tech pioneer commercializing quantum tech applications. From the Siemens side, Professor Dr. Wolfgang Mauerer is joining us here. Wolfgang Mauerer is a senior research scientist at Siemens Technology and a professor for theoretical computer science at the Technical University of Applied Science in Regensburg. He has worked with various aspects of quantum computing and quantum information for the better part of 2 decades. And last but not least, Dr. Sebastian Luber is Senior Director Technology and Innovation at Infineon Technologies. Sebastian Luber holds a PhD in physics. As a spokesperson of Infineon-wide expert group for second-generation quantum technology, he represents Infineon in a variety of external bodies and activities. Among other things, he was a member of the German government's expert council for a national quantum computing roadmap. In addition, Sebastian Luber is active as a working group leader in QTech, the German Quantum Technology and Application Consortium. So very decent panel board to discuss that topic, which is also part of the discussion of my Bitkom working group for HPC and quantum computing, really how to look on the success and the evolution of quantum computing, especially in Germany, but also on a broader scale on a Europe perspective, compared to the US, North America environment, but also to Asia Pacific. So German public objective and roadmaps for quantum technology and quantum computing in particular have been outlined over the past years. Extensive funding programs have been started on this basis. How do we look today at our vision and define targets for quantum computing and the progress of the implementation? And that's the main theme for our panel here today. And what I like to do is to start with the status of strategy and implementation. An holistic quantum computing ecosystem is considered critical to reach and to maintain a leading position worldwide. This comprises basic research transfer into industry for development and production of quantum technology, as well as early availability and adoption of quantum application across user industry. And looking back to the keynote speeches, this was already part in many of those speeches. So let's start with a pretty easy question. So what is the progress in our position in these key pillars today? To start the discussion. And I'd like to do a roundtable to everybody for a short answer in that direction. And let's start with Ina Schieferdecker from the BMBF from the government side.
Yeah, thank you, Ingolf. Of course, simply speaking, we have a clear roadmap. We have strong stakeholders, but we don't have the large tech companies which are present in other parts of the world. So I would say there's excellent research. We do have hands-on individual components. We have a plan towards the overall system integration, but that is the homework that still needs to be done. And for that, we believe that we need to have new players on the field. That's why we also look in all our calls that we find conditions and that startups can contribute to the projects or are being created.
Let's see how the technology providers are looking at that. So let's start with IBM and Heike.
Quantum computing has gone through really quite a lot of development, and there has been already also in Germany a lot of research going on and excellent education of researchers in quantum technologies and quantum computing, which is seen also in quantum technology, quantum sensing companies, etc., startup companies, etc. And when we look worldwide, there is, of course, a lot of things still need to be done, because quantum computing and the quantum ecosystem is still in its very early stage. So research and development and building the quantum systems, which comprises, of course, the entire stack from the hardware to the software, the electronics, the control software, Qiskit, etc. All this has to be strengthened and built further up. The supplier ecosystem in order to really make this quantum computing technologies and quantum computing as a field successful. But I think in general, we are very, very good. We are on a very good track because we were able to also build up roadmaps and start to deliver on those roadmaps. And that, of course, gives also a lot of confidence to the field.
Okay, thank you very much. And Sebastian, what's Infineon's view on that?
Yeah, I think in general, we see a very dynamic situation regarding quantum computing. And this is also, so at that point, thank you to the Ministry of Science. I think there has been a great movement, a great momentum created by these funding schemes, which you have seen at that site. We see many startups, I think, popping up at every corner. We see industries, so like, for example, Infineon a few years ago also entered this field. And also on the application side, we see consortia forming, like this Quantum Technology Application Consortium. So I think the momentum is great, but one also has to be, I think, realistic that it's rather not a sprint, it's a marathon, a long-term effort which we need to really reach this stage of quantum advantage. And this is also my hope, or my view, that we need a kind of continuous effort for the next years to really reach this state.
And the view of Terra Quantum, so Markus?
Yes, I mean, I represent, of course, the perspective, of a young company, a scale-up company in that field. So probably a little different view. I think on a global scale, I would agree, it's a great dynamic in that field. Yeah, I think the US and China, are pushing ahead. So we in Europe and then we in Germany, have to really concentrate our efforts to make it happen. And I think we, of course, have the challenge of that heterogeneous landscape within Europe. And therefore, I think it is very, very crucial that we have a strong and very close cooperation in Europe across the various nation states. And we have a great research landscape, great universities, but the transfer into industry, the production of quantum technologies, I think we lag behind. And I also would strongly vote for the position that, we have to support young companies here in that field, because if you look at other industries and who has disrupted them, take the automotive industry as an example, it wasn't the incumbents actually with new technologies, it were startups, right? Or one very prominent startup. So I think this is what we have to really try to intensify our efforts to support a young industry here, emerging startups and scale-ups in Europe and Germany.
And what you are thinking are the main challenges here, and what's required to tackle them, Markus?
Yeah, so I think the most important part is, of course, access to private capital. Yeah, so we are coming back to the situation that we have to compete with other regions in the world to finance these young companies. So we need an active ecosystem of venture capital companies who want to support also German and European tech sovereignty. And I think that must be a focus. And all these subsidy programs on various levels, we do see very good initiatives here on the German level with those 2 billion. There are also some regional initiatives like the Munich Quantum Valley. These are all great initiatives, but they have to be combined and they have to have a very practical focus on how to deploy the money and bring it actually into these companies.
Yeah, and that's a few, let's say, from a startup perspective. I think Siemens, as big company, is having a different perspective here on that, Wolfgang.
Probably slightly different, not entirely so. I guess I can agree to most of what my co-panelists said so far. I do agree that we have a very strong state of fundamental research in Germany, also in Europe, and basic hardware research, quantum theory, quantum mechanics research. And I also think we have, at least if we look at all of Europe, a very exciting ecosystem of what concerns production of quantum technology in various aspects, in sensing, in computing, in other things. The key challenge, in our opinion, is, of course, the transfer into industry, because that is something that is not on the agenda of where our current strengths are. So basic research is not necessarily concerned with transfer into industry. And this is a thing that often is seen as a trivial thing to do after you've published your sensational paper, and then it automatically goes into industrial application. But that's far from it. And here we still need to better recognize the challenges that engineering and also engineering science, engineering research brings when we turn something from an optical table or a physical lab into something that can be deployed in industrial context. So I guess the kickstart given by the government, I have to second Sebastian's opinion, that was very helpful to get things moving, but especially on the transfer side, we're looking at the marathon and nothing that will solve itself automatically in the next couple of years.
Yeah, and looking back to last year, it was quite an interesting election. And according to the coalition agreement, the new government plans to further development research programs and high-tech strategy in quantum technology in a mission-oriented manner. So measuring against international target categories. So question to Ina and the BMBF from the government side, which mission are in your opinion here particularly relevant?
I would clearly say that the mission of our program is to establish a strong European quantum computing ecosystem. So we want to develop or support the development of competencies in the industry. We want to really leverage the research results into concrete applications. We want to see the quantum supremacy in various application domains. So by that, we simply state that, we see it like coming from both ends, starting with the needs where we do have unsolvable problems by current computing facilities, or which can be solved only suboptimally. So there's a need. For that, we come from the infrastructure hardware perspective on the one hand side. As I explained, we start with all the potential technological platforms, but also we start from the application perspective, where should the final quantum computer-based solutions be? So for that, either with simulation approaches or with first application scenarios, software stacks, we want to sort of say come from both ends and have the touch point at the end that sort of say general purpose error correcting quantum computers could work out. The mission is, and it's understood that it's, of course, a deep tech roadmap that we follow, but for that we need the people in research, in industry, in the application fields, and for that we have a combination of strong research projects with industrial partners, strong industry projects with research partners, and supporting projects which develop the needed competencies for the workforces. So that at the end, we give the needed support to find the new business cases which address the societal challenges in large scale.
And
may I just add? So I just want to emphasize this topic of the application orientation, because I think in the end, a user or somebody applying this technology does not care so much about this quantum insight. I mean, I'm a physicist, I'm fascinated about this topic, but in the end, you're only interested, you have a task to solve, a problem to solve, and you want some machine, something doing that. And so that's also, I think, extremely important in the overall effort. So on the hardware side, we have to provide the solution to enable this, but we also have to look at really the situations, at the task, at the use cases where this fascinating technology really brings a benefit to the business in the end. Because once you have a benefit to the business, then again, you channel a lot of money to the development. You have seen this in semiconductor industry as well. So once you have the first revenues, you have this additional development of new litho nodes, and then you have this great cycle with extremely great business. And I hope to see the same for quantum.
Yeah. So actually, if I can also add, Ingolf, if you don't mind, because I think you asked before you asked for the challenge, and then you asked for what is the critical mission or what is relevant also internationally. And I think it's actually the same thing everywhere, because we need to develop this new computing technology as a technology which can provide advantage to the one who wants to apply it, right? And this covers, of course, everything from when you look at the challenges, the big challenge is, of course, to build the computation and the computational hardware into a way that it's large enough to solve a critical problem. But on the other hand, also develop the software environment, develop the applications which are relevant for the industry, because in the end, it's a big industry who wants to benefit of using this type of compute. And so for us, important and a big challenge is, of course, to scale the computers, to increase the speed of the computers. So this means to increase the speed of the quantum computation, optimize the full system, optimize the classical and the quantum computing architecture that they can work in concert together, and also improve the quality of the computation. So this means in the end, we are weaving quantum processors, CPUs, GPUs into a compute fabric to solve problems beyond the scope of classical resources. And that goes in hand, of course, to build the quantum-centric supercomputer. And I think this is what the user in the end want, because the user doesn't care, as has been mentioned before. Also, is this a quantum computer? Is this an AI hardware accelerator? The user wants to get a benefit out of the new technology. And this is the big challenge, of course, to demonstrate this also and to build the corresponding ecosystem that all the players fit together and can provide this advantage to the industry.
And that's an interesting and good point, which is leading me to the next question, applications and users at the end. So creating research networks for application was defined as a major objective in the government program for quantum computing. And the question here is, and I'd like to start with the startup, with Terra Quantum. Where do we stand today with the development of such networks and with the definition and development targets of target application, and especially looking on the aspect of cooperation between different companies and organizations and academic institutions, Markus?
Yeah, let me probably focus on that aspect of the cooperation between actually industry and startups, because we are, although we are a startup, a commercial company, so we look for real kind of business models which are successful in the end. And that's why our approach actually is quantum as a service. So we want to really kind of bring quantum technologies and applications towards the corporation so that they get started and see an early benefit of using quantum technologies. I think that is really crucial to have that thing and that industry kickstarted, that large corporations see early benefits in quantum. And I think the way to do that is actually by applying hybrid technologies. So in the successful combination of high performance computing and early quantum computing hardware on the hardware side, and then on the software side, also mixing classical and quantum algorithms. That hybrid approach is a short-term, shows a short-term benefit, but it's also mid and long-term a very wise thing to do, because you will always combine these technologies. And that's what we do. And by doing that, you can already develop a software stack, a quantum software stack, develop quantum algorithms which tackle specific use cases, and then deploy them on virtualized qubits so that you see the impact of that. And by doing that, actually, we achieve a quantum performance increase already today for various use cases and have them in industrial productions with large corpus. Because I think that ultimately is what is most convincing for corporations, if they see there is a performance increase. Yeah, and whether that's hybrid or pure quantum is kind of a second priority for these companies.
And how important are collaboration and networks for that?
Yeah, I think they are important, right? I mean, this topic is so massive, the markets are so huge that everybody should be invited to cooperate and kind of be a vital participant in a vivid or in a very lively ecosystem. And it is important. So especially also to the combination with academics and universities is important, because those talents which we need, we have now kind of hired more than 110 quantum physicists around the globe. You get them from universities, right? So therefore, it is very crucial to have a good research cooperations with universities to attract the talent which is desperately needed for this new space.
And Sebastian, how do you working in collaboration with universities and other companies, with tech providers here in that manner?
Yeah, I think has been already mentioned, it's still a challenge to get access to all the knowledge, because it's such a broad field. So in my opinion, collaboration is key. And there we have different approaches. So of course we have, for example, as already mentioned, these funding schemes of BMBF, where we have also Infineon participates in large consortia together with university research institutes, but also other companies. Then we have other consortia like QTech, where we work together across companies, which I think at this very early stage is benefiting for all of us. And then later, of course, you have to differentiate. And so in general, partnering for me is key at the moment. And then, together develop the whole field forward, where everybody benefits. And then later, differentiate and compete, because this then further accelerates. And also very nice, of course, what helps now is that finally we are at the end, hopefully, of the pandemic. So people start to meet, as for example, 2 weeks ago on the World of Quantum with the BMBF networking event. And this definitely is a push for the whole collaboration. So really looking forward to it.
And looking a little bit in the future, Heike, what is necessary to achieve broad adoption and exploitation usage of future quantum advantages across economy and the industry?
Yeah, I mean, so as mentioned, I think before, the user really wants to have a benefit, right? To be able to apply quantum computing for a commercial benefit in the end, and to get this advantage in solving a certain mathematical problem. This means you have to be more accurate or faster, or can solve a problem which we are not able to solve by classical computer today. And this is the vision, the goal we are working on. And today, I mean, you guys have discussed now also the collaboration. I think that is really very crucial to collaborate, because there are still a lot of fundamental things also to develop in the application space, in algorithm, in getting experiences. And I think not everyone should make the same mistake, right? Because also I think Ina will be happy if not everyone makes the same mistake. But if we share the mistakes and then progress and build on top of each other's work, that we can accelerate and can have much, can reach that goal much faster. And this is actually today we have here a partner event where we have like 70 different partners here. And it's very nice to see how they engage with each other, people who work on the same use cases, or people sharing experiences of using quantum computers, etc. And this will be relevant, of course, for the broad adoption. That's one part. The other part is also that it's easy to access and easy to use, right? I mean, computers were very difficult to use and only quantum physicists can use. They're not useful. So it has to be also built in a way that software developers, engineers, etc., can use it, and that it's that we can also bring quantum computing frictionless into the other compute hardware, that it works in concert with the other hardware. And in the end, the user doesn't even know that you solve your problem, which you need to solve on a quantum computer.
Yeah. And when I'm looking to Siemens as a big company, what's your perspective on that, Wolfgang?
Well, I'd like to come back to an argument that Markus made before about quantum computing as a service, which is one way towards achieving quantum integration in commercial products for large companies. But I think we haven't mentioned yet another aspect that is very close to my heart and very close to, say, traditional manufacturers like Siemens, who build industrial infrastructure equipment, who build medical devices, who build, in short, embedded systems that are not high-performance computing systems. So going for high-performance computing is one thing that is extremely important, extremely interesting. But from our point of view, quantum advantage will come from integration into, like already Heike said, existing computing products. And these computing products need not necessarily be the flagships that we produce. That can be some industrial automation device that then solves with an imperfect, noisy quantum computer perhaps one task that is very specific, but that is very important to the industrial users. And we don't even, I think, need these sensational speedups. We don't even need exponential speedups. We don't need to solve anything that was totally out of reach before. We just need something that is a solid advantage. Because if we look into hardware, gains in hardware development, like that came from GPUs. From a fundamental point of view, GPU is boring. It's just the same device like a CPU, a little more of them perhaps, but the gains in some are exceptional. And it's the same thing about quantum communication. So when did commercial interest in quantum communication pick up? Not with the papers that did unconditional security proofs, not with the latest fancy methods to do this and that, but when people realized what the drawbacks and the failures of these devices were, because then we could get a realistic understanding of what to expect and what the next steps are. And I think finding these problems that are very specific, that do not need full complete quantum computers, error-corrected quantum computers, but they do one thing well and give us experience with the whole system integration. That is going to be the second very important step forward.
I think, so if I just want to add, I mean, this is really, I think, a very good example, because if we look in computation in general right now, the performance is, we get out the performance by specializing compute for applications, right? Before it was general processors, which we use for general things, and that was okay. But now we get the performance out for really specializing things. And I think that's, I think, also important for the companies now to figure out where are these advantages for your specific business, and then also have easy access. And that's why we also, you know, have these different models which we bring and which you see at our roadmap to get access, have different compute as the quantum as a service, where we have the quantum application modules in different areas, whether it's in optimization and physics and chemistry, that's really targeted to make it easy for you to use it in your specific application. And then also, you know, sources through the cloud makes it also for easy to consume. And that's, I think, the model which we would like to use, and also make it easy for people to then apply quantum computers for their specific applications.
And looking on that, that's very much, we discussed the German perspectives, but there are big programs in Europe and also on a worldwide level, but the European Quantum Initiative is quite big, with a lot of money in that. And there's also some competition between Germany and Europe on a certain extent. So, Ina, what role like Germany to play in the European quantum ecosystem here, and what are the challenges, or what do we like to support here?
Thank you for that question. Indeed, I could reply that the answers have been given before, because the answers are that quantum technologies are complex matter, and we cannot sort of say realize or solve the open issues in a standalone approach, so that it's always about cooperation with the European and other international like-minded partners. So we want to be a strong partner, active partner, and we want to make research, well, at best, directly usable, transferable into society, industry, applicable by the end users. And for that, we really look forward towards the Euro HPC and the Euro QCI, which is about the pilot infrastructures in Europe, so that computing services, including quantum computing, large scale, small scale, high performance computing, or special purpose computing can be supported.
Yeah, and from a company perspective side, cooperation competition is here a very important topic. And especially international companies like IBM, but also Infineon in an international market area is affected by this. So when we are looking to that out of an Infineon perspective, how do we approach cooperation versus competition here?
And in general, I fully agree. I think competition is a very good thing. It's always good in a positive manner to compete with other teams, with other approaches. This usually pushes you when you have the same, of course, the same boundary conditions. And I think we have a great environment in Germany and Europe. So I'm convinced that we have everything which we need in order to play a leading role. And I'm very much looking forward to kind of contribute to that. Regarding this field, as Heike mentioned, I think very important, as it's still kind of very often here, it's a kind of a challenge given by nature. So there's still so many physical challenges to be solved that at that point, to address these topics, it's very, very important that we share kind of results. So it's a collaborative approach and that the overall field is progressing by learning from each other. Regarding the business, of course, it's pure competition. I think that's good. And there I also think that we have to be completely open-minded. So we already heard that one approach might be the supercomputer, quantum supported or quantum accelerated, or the not so perfect quantum computer in some standalone solution. And I think there it might be that we find some business case in a completely different area, inspired by the development activities which we are doing right now. And there, I think it's very important that we're open-minded and that we also have them kind of flexible boundary conditions, that we can adapt perhaps the funding to also to this area. So for me, it's a mixture between cooperation, where it's still very much on the basic research side, and then competition when it becomes more closer to the business side.
Oh, the old co-opetition story take place here. So
hopefully.
Let's use the last minutes from my very interesting topic, measuring and monitoring of progress. So let's do a short roundtable. Looking into the future, let's look to 2027. So in 5 years, where we are there and where we like to be there, and how to measure that. What might be a good approach to show the government environment, but also the people environment, that we are successful. What are your opinions on that? So where we are in 27 and how to manage measure success here in that direction, for example, which can be done by the Bitkom environment, asking different people and building up a specific report on that on a yearly basis, for example. So what are your thoughts on that? And let's start with the government, with Ina.
Yeah, of course, government has always many indicators, but as you ask for 3, I would start with the impact perspective. So We would like to be very successful in commercial use cases and service offers for quantum advantage. Then second, we want to have a strong ecosystem counting in terms of companies, startups, spin-offs, workforce. And well, on the research side, of course, we want to be strong with having a clear view on the technological platforms up to the applications. It doesn't need to be one, but it should be successful ones so that we address the requirements from the society.
Heike, IBM's perspective on that.
Yes, so Ina has already mentioned there are many, right? We also have many, but I think really the most important one is our roadmap. And you know, in 2016 we have released the first 5-qubit processor to the world through the cloud. We have then in 2020 built a roadmap for us where we disclosed and our ambitious goals which we have. And just yesterday, actually, we released an upgrade on the roadmap of how we want to develop further to 2026 is the end of this one. But this means like 10 years of development, and we want to go from 5 to 5,000, which is a good growth rate, I would say. And you see there also not only the hardware, how we develop it, and I would encourage you to read the blog and go through it, but how we develop the entire system from the hardware, how we build modular systems also for different purposes, how we integrate this into the compute world, which I indicated before, and how we build quantum Qiskit runtime and build applications which I described before that make it easy to use for our partners. So if you look at the roadmap, you see how we measure ourselves.
Okay. Markus, your view and short answer, please.
Yeah, what Ina said, I think, is very much true. I think these are the most important indicators. So real commercial use cases, number of quantum enhanced industry applications really being at work. And I wouldn't forget, I would mention one other aspect, that's the number of patents, actually, number of patents in that field, which are kind of initiated by German/European companies, because there is a race on patenting all that stuff.
That's a good point. So Wolfgang, your view?
Yeah, so I think we need to make it quick to understand a path to realistic integration for realistic problems. You may also call that a roadmap, of course. We need to know the right level of abstraction and integration. I think that's going to be key to building systems that actually matter. And I'd like to raise a third point that, to my astonishment, has not been raised before. That is, we have to have quantum knowledge as part of standard engineering education. So no engineer who leaves a university should in 5 years' time be without quantum knowledge, because that's the workforce we're going to need.
Yeah. Very good points, the last point. And Sebastian, your view?
Sorry, many things already said. So of course, I think economical figures are important, but in general, I can just emphasize that it's very important to measure the success. But in addition, perhaps just to add a very small thing, what would be great, I think, if we could demonstrate that quantum technologies or quantum computing is contributing to solve some of the socio-economical challenges which we have. So perhaps solving a problem with less energy, so reducing the energy consumption, or perhaps even contributing to some better processes, which in some chemical reactions might reduce overall energy consumption, so that we get really a positive impact of this new promising technology to the challenges which we face.
Thank you very much, team. And I was writing up everything here in our last round, because that will be something what we like to progress within our Bitkom working group. And I'd like to thank you for your participation and the interesting discussion here in that panel. And I'd like to give back to the Bitkom moderator.